this is a plunger and this is a syringe, and we use this syringe in the experiment to understand the relation between pressure and volume. Now if I have this syringe again and I try to fill up all this syringe with a liquid, so for example in 6 ml here I will add a 6 ml of liquid inside this syringe, and then I just pull up, okay, I pull out this plunger in half away, so that means I increase the volume. So the result will be that the volume of liquid will increase the volume of this space inside the syringe. So why that happen? I have an amount of water, for example, inside the syringe, and when this plunger just move out, okay, or just I try to pull this plunger out half away, the volume inside this syringe will increase and the liquid will occupy all this volume. Why that happen? What do you think? So if this is a liquid inside the syringe and this is a plunger, okay, so now I will pull the plunger out half away and look at the particle. It still occupies all the volume inside the container or inside the syringe. Now again I will decrease this mass and look at the volume. The volume increase and all this liquid particle occupied all the space inside the syringe. So why that happen? Look what the difference here. Look at the particle. Here this particle is very close to each other. So here look at the particle. When we decrease the volume, this particle become very close to each other, and that's why, okay, the volume decrease. So this particle still have a space between each other, but we have this higher collision between particle, and this particle are very close to each other. If I increase the volume, the space between particle increase. So now I will have a more space between particle. Now I increase the volume. Look at the space between particle. The space increase. I have more space now. Look at the pressure. Look at the pressure. I increase the volume. What happened to the pressure? What happened to the speed of particle? What happened to the number of collision between particle and the wall? Look at the volume. I will decrease the volume again. Sorry, I will increase the volume again. I increase the volume. This is a very large volume, and look at the particle. The particle will occupy all the space inside the container, and I have a very low pressure. I have this particle and just move in a very slow motion comparing with this particle. Look when I decrease the volume. Look at the volume. When I decrease the volume, look at the space between particle. The space between particle decrease. So look at the space between particle and look the the pressure here. The pressure, what happened to the pressure? It's increased. Look at the collision between particle and look at the space between particle. I increase the pressure and now look at the pressure now. It's increase or decrease. So if I decrease the volume, the space between particle will decrease and the pressure will increase. So I decrease the volume, the space between particle decrease and the pressure increase. If I increase the volume, look at the space between particle increase and that make the pressure decrease. Okay, so the space between particle increase when we increase the volume and the pressure will decrease when I increase the volume. So I will add it first, a particle. Look at the pressure when I added particle. Look, I added this amount of particle and I have a 8.6. Okay, between, yes, like 8, just atmospheric. Look what happened to the pressure when I added more amount of particle. We increase the pressure. So the number of particle effect on the pressure. So if I change the number of particle, the pressure will be changed too. Now, because I just want to study the relation between volume and pressure, that means I should make the temperature constant. So I have a constant temperature now. So I want to study the relation between volume and pressure. So look at the pressure. Now I just added this amount of particle. Look at the source of energy. We don't have any source of energy. Why? Because I want a constant temperature. So that's why they remove the energy. So here inside the container I have a particle. And now we can study the relation between pressure and volume. Now, this is an particle and this is a pressure. I want you to look at the pressure, okay, the reading of this pressure here when I change the volume. Look at the volume. Look at the volume. Look at the volume between particle. Look at the space between particle. Look at the space. What happened to the space between particle? Look, what happened? What happened here? What happened to the space between particle? What happened to the pressure? The reading of pressure change when I just change the volume. The space between particle decrease when I decrease the volume. The pressure increase when I decrease the volume. So why the pressure increase when I decrease the volume? What happened to the speed of particle? I want you to look at the speed of particle when I have this large volume. I have this large volume. Look at the space between particle. I have a large space between particle. And now I will try to decrease the volume. Look at the speed of particle and look at the collision between particle when I decrease the volume. Look what happened when I decrease the volume. Look at the speed of particle and look at the pressure. Look at the number of collision between particle. Look at the particle. So the number of collision between particle increase. and that means I will have more amount of particle that collide the wall inside this container. So in the result, if I have a more and more number of particles that can be collide this wall, that means I have a more than one force will be applied in this surface area here inside the container. So that means I will have a very high pressure. So I have a high pressure now. And all that just result from decreasing the volume. So I decrease the volume, the space between particles decrease. That means the particles very close to each other, and then they start to collide each other and collide this wall here inside the container, and in the result I increase the pressure. Now if I increase the volume, look at the pressure, I will increase the volume. Look at the space between particles, I increase the volume, okay, and the space between particles increase, the pressure decrease. Look, the space increase. Look at the collision, look at the speed of particle. Now the particle move very slow. That's why, because I increase the space between this particle, and in the result I decrease the number of collision between the particle and the wall. If I decrease the number of collision between the particle and wall, that means I decrease the number or the amount of force that can be applied in this wall here, and in the result I decrease the pressure. So that's why the pressure will decrease when I increase the volume, because I will have more space between particles, so the number of collision between particles will decrease, and in the result I will have a very low force applied in this surface area here inside the container, and then I will have a very low pressure. Now look here, the pressure increase, okay, when we have a less space to move around. So this particle will have a less space between each other, okay, so that result from decreasing the volume. So if I just compress this container, I compressed all these particles inside the container, that means I decrease the volume. That means the number of collide particles between the particle will increase, okay, so that means the particle will collide each other more and more. But if the volume increase, if I increase the volume, the pressure decrease, okay. If I increase the volume, the space between particles increase. In the result, the pressure will decrease. Why? Because the number of collision between particles will decrease. That means I will have a less number of particles that can be collide the wall of container. So that means I will have a very low force that applied in the surface area inside the container. In the result, I will have a very low pressure. And here we have this type of experiment. It's an scuba diver experience, okay? So for pressure. So when the scuba diver just try to swim under the water, he will feel with the pressure inside her air, okay? So inside their air, he will feel in the increasing of pressure, okay? Why? Because he moved down inside the water, so he moved down, okay, so he will feel with increase or decrease in pressure when he found inside the water. That is one example about the pressure and volume. Okay, the relation between pressure and volume. So when he just move down inside the water, the pressure increase more and more. Okay.
An important physical factor is the pressure affecting our body while diving. The deeper we dive, the higher the pressure is. In general, pressure is determined by the weight caused by a body affecting a certain area. The smaller the area affected by the load, the higher the pressure, and vice versa. The pressure of 1 bar is generated by the weight caused by a body with the weight of 1 kilogram on an area of 1 square centimetre. Alternatively, a water column with a height of 10 meters generates
the pressure and volume law. And the pressure and volume law is described by Paul's law. Okay, so this relation between pressure and volume comes from Paul's law.